In this video, we will be looking at an example of finding the slope of the tangent line to a curve. Press pause to copy down this definition. When you're ready to continue, press play. In our example, we're asked to find the slope of the tangent line at x equal -4 of the curve given by f of x equals 4x minus x squared. We're going to use this definition. So we write m equals the limit as delta x approaches 0 Now we want, in place of x in our function, we want to sub in x plus delta x. So in our function, we have 4 times the quantity. In place of x, we're going to take that x out and put in x plus delta x. Subtract. And again, in place of x, we're going to put in x plus delta x. Quantity squared. Now this right here, this binomial, that represents f of x plus delta x. Now I still need to subtract from that f of x. Let me put a bracket around that, and we know that f of x is 4x minus x squared. And then in the denominator we have delta x. Before we can find the limit, we need to simplify this a bit. And just copy delta x approaches 0. Distribute our 4. So 4x plus 4 delta x. Now this delta x is a variable. Don't separate the delta away from the x. It's not a product. It's delta x represents that very small change in x. Right? And then we're going to have minus, and we need to square this binomial. So I'm going to wait and pull my minus through after I'm done squaring. Squaring x plus delta x gives me x squared plus 2 times x times delta x plus delta x squared and then we need to distribute this minus through their binomial. So we'll have minus 4x plus x squared all over delta x. Let's go ahead and distribute that negative, and then we can look to see what can cancel. And the limit as delta x approaches 0. I'm just going to copy 4x plus 4 delta x, and then minus x squared minus 2x delta x minus delta x squared, and then copy this back here, minus 4x plus x squared, and that's all over delta x. Now let's look to see if we can cancel some things off. We have a 4x and a minus 4x. Those will cancel. We also have a negative x squared and a positive x squared. Now the thing is about finding this limit as delta x approaches 0, I can't do a direct substitution in here as it is because you can't divide by 0. So what I would like to do is look at each of these terms that are remaining and see if there's a delta x that I can factor out and then cancel with this one in the denominator. So we have limit delta x approaches 0. I have 4 delta x minus 2x delta x minus delta x squared, and then everything else is gone over delta x. So as you can see, we do have a delta x factor in every term. So let's factor that out. And when I take the delta x factor out of this first term, I just have 4 left, minus, when I take the delta x factor out of this term, I have 2x. And then when I take one of these delta x factors, because it's squared, I'll still have one delta x left. And that's over delta x. So we can now cancel. And we have the limit delta x approaches 0 of 4 minus 2x minus delta x. Right. Now there's not a problem with direct substitution. I can put a 0 in here in place of delta x. And I have, this is equal to 4 minus 2x minus 0, which is 4 minus 2x. So our slope of our tangent line at x equals negative 4 is going to be this equation. Now this is the slope of our tangent line anywhere on the curve. So if you wanted to find the slope of the tangent line when x equals 0, you would put a 0 in here and find that slope. When x equals 3, you'd put a 3 in here for x. So our problem says, what is the slope of the tangent line at x equals negative 4? So the slope at x equals negative 4 is going to be 4 subtract 2 times negative 4 plus 8. So our slope at x equal negative 4 is equal to 12.